Alright, Noah here, the Y. But I got my little golden freaking clickety clackety clock. I love these things, they're so annoying. Um, but today we are going to be reading Solar Electric Independent Home Book, published in 1989. Revised in 1991, 2 years before I was born. Let us start, shall we? By Fowler Electric Incorporated. Introduction to solar electricity. Lovely. Blah blah blah. This book is a product of years of bullshit. Blah blah blah. Blah blah blah. Introduction to electricity. Blah blah blah. Not gonna mention freaking how much anything costs, because whenever you put money signs in front of something, normally there's a lie involved. We're just basically going to get down to the actual, the way that shit works, and so everyone can know the truth about how they can actually do it by themselves, and just a bunch of misconceptions that people tell about electricity. So, you know the truth and you can do it yourself. It's extremely simple. Alright, first we have some diagrams. Short circuit. Lovely. Normal operating conditions. La la la. Let's get to actual, oh yeah, this stuff. These things right here, you can see the specs on it, but consider they had that in like 89. My solar panels are 400 cells in series. These are 36 cells in series. Let's just get to the information that tells you the truth about things. Meters. 1 voltmeter and 1 ammeter are imperative in any system. It is easiest to order these as a factory option and get meters that are matched to the size of the unit. Most meters will only be standard analog meters that are not very accurate. This will still be fine. The ammeter need only indicate that the modules are producing approximately the right amps. The voltmeter can be calibrated with a digital voltmeter upon installation. Load disconnect. Small DC loads pass through the controller before distribution. If the battery discharges too low, the controller automatically disconnects all loads. The loads are not reconnected until the batteries are charged again to 75% level. Good system maintenance in your own home is far better than low voltage disconnect. If you have a weekend cabin, or if you travel and are forgetful, you might need this option. A normal good-sized system powering a forgotten light will never trip this device anyway. For good wiring, DC loads should be powered from the batteries directly whenever possible. If a low voltage disconnect is a must, we recommend using a Trace C30 load disconnect separate from the charge controller. Temperature compensation. Battery storage capacity and full charge voltage level are dependent on temperature. The charge controller with the temperature compensation option self-adjusts its voltage disconnect points according to temperature. Obviously, if the sensor is internal to the charge controller, then the controller must be installed in a location that is the same temperature as the batteries. This option is normally considered when the battery bank is less than 20 degrees Fahrenheit. The best solution is to find a better place for the batteries. You may also select a charge controller that has field settable voltage points. You may set voltage points higher for the winter. Array diversion. When batteries reach a full charge, the array current is switched to another load. Only under special cases can this be used in a remote site home system. The array current can be switched to another battery bank. But you will need an additional charge controller to keep the second bank from overcharging. Any other option to use the diverted current must be able to take full range of amperage and voltage from the array. Few appliances will not damage in this situation. Now, this is from '89, so remember, we have much better technology where we can have just shit built all into the freaking charge controller. My charge controller has many safety settings to where it's very nice, very nice. I got it from HQST, Mountain something something. But I ordered those off of Wish a while ago, and they're the best damn solar panels I've ever had my entire life. My buddy even drove a 2-ton van over it. It freaking bent the thing in half, and it still works perfectly fine. Better than Pine. The most difficult assignment in a book of this nature is to include the necessary information, but not too much information. For simplification, we will concentrate on lead anatomy, deep cycling batteries at the current level of battery production and technology. This is one good choice for a remote site home installation. These batteries are, of course, not ideal for PV use, but the economy of scale dictates a price that compensates for their less than perfect design. Bleh. There are superior designs of batteries such as Absolute. Suspended electrolyte batteries. The life is longer, the temperature range of operation is better, and the maintenance is negligible. However, the price is prohibitive even when after factoring in the increased lifespan. The battery industry should develop a battery specifically for home PV systems. Until your first battery bank replacement, use the deep cycle battery, like marine batteries or RV batteries. Maintenance-free batteries are available for PV systems. Some are sealed with liquid electrolyte, some are captive electrolyte, and some are gel cell. This sounds great. They need no addition of water and will not gas. However, there are problems. You must actually be more careful with them than standard deep cycle batteries. These batteries will not gas only if they are charged at no more than their maximum recommended charging voltage. If this is surpassed, the battery may be damaged. The least damage you will be that the batteries will gas and the gas will pass out of a pressure release vent. Unfortunately, you will have no way to later add the lost water that was broken down to create the gas. I call nonsense. There's always a way with a will. You will be able to set custom charge controller to match set points needed for maintenance-free batteries. The problem occurs if you ever have a charge controller that fails and does not disconnect the modules from the batteries. If you are away, then you could lose the whole expensive battery bank. Man, batteries aren't that expensive anymore. We can create them out of fucking pennies and fucking vinegar. Here we go. Inverters. The inverter is potentially the weakest link in the remote site home PV system. It is a complicated, expensive piece of electronic technology. Which is most owners come in the shape of mysterious large black box. Inverters for PV homes have come a long way in the last 7 years. The best inverters are very reliable, no shit. They will require less warranty service than a generator. The majority of all of them will never do anything but run. Most PV homes will either immediately or in a short while need an inverter. PV system is the most simplest analysis. It is a battery bank and a battery charger. Modules and batteries produce and store DC electricity. DC current moves. In most remote site homes, it is supplied at either 12, 24, or 120 volt. Alternating current moves first in one direction, then stops its flow, and then flows in an opposite direction. This sequence constitutes one cycle. The change in flow is not obvious because there are 60 of these cycles occurring each second. Thus, utility current is 120 volts AC at 60 Hz cycles a second. An inverter is an electronic device that takes an input of DC electricity and produces an output of AC electricity. In low voltage systems, the inverter transforms the low voltage electricity to 120 volts electricity. The first job the inverter does is switch the current on and off while it also keeps reversing its flow. This produces an alternating current which is still at the original low voltage. This is then put through a step-up transformer that yields 120 volt AC electricity. The switching must also be performed at a precise speed to produce 60 Hz. The abrupt switching of a simple inverter produces a square wave, which is actually a graphic representation of how the current is flowing. Utility current flows in a sinusoidal wave. Its current is switched on and gradually increases until it reaches a peak, then gradually decreases to off, and gradually increases in a negative direction. Load demand. This is necessary on all remote site home systems. An inverter that is turned on is supplying no load, still consumes 8 through 40 watts. Load demand has a circuit that waits for a load consuming only 1 to 4 watts. When load is applied, it senses it and turns on the main inverter. Overload protection. If the inverter is overloaded by a large appliance or a short, it will shut down. This is normally done electronically. The unit turns itself off. It is also done thermally for loads just over the inverter's limit. The inverter becomes hot running a large load too long. Direct wiring. In addition to the receptacles, the inverter can be wired directly to a service panel. DC breaker circuits. The circuit breaker disconnects the inverter from the battery bank. If one is not supplied with the inverter, some sort of fusing must be wired between the battery and the inverter. Remote switch. Additional wire and switch are supplied to allow an inverter to be turned on and off from another location. Standby option. The inverter is equipped with a large battery charger to be powered by a generator for backup charging of the batteries. This option includes an automatic transfer switch that connects all loads powered by the inverter straight through to the generator whenever the generator is running. Stacking option. An interface for electrically grouping two inverters so they will function as one double-sized inverter. Neat. Thermal cooling. This is a thermal sensor and a fan to cool the inverter or battery charger when it produces a lot of heat during sustained heavy loads or heavy charging. It improves the inverter's efficiency and keeps it from disconnecting from overtemperature. Digital multimeter. A metering system that is internal to the unit monitors battery charging from a generator when the inverter has a standby option. Low voltage disconnect. Many inverters have low battery disconnect, but it is set to protect the inverter if the batteries are dead. This optional low voltage disconnect has adjustable set points to shut off when the batteries are low but far from dead. La-di-da. This is all for old shit, man. Oh, yeah, that's Independent home as a whole. When designing a PV system, the remote site homeowner is always faced with a choice of whether to use AC or DC. The smallest system, which only operates a few lights and a radio, is probably best to run on DC. 12 volts is standard voltage used in automotive and RV industry. Incandescent bulbs, car stereos, TV, fluorescents, and many appliances are readily available at local stores and from mail order catalogs. The other bonus of the 12 volt system is the high efficiency. A 50 watt 12 volt incandescent bulb produces as much light as a 100 watt 120 volt light. This is not magic. A 12 volt bulb at 50 watts draws 5 amps, while a 50 watt bulb at 120 volts draws 0.4 amps. Tungsten filament designed for larger amperage produces more light and less heat. For a simple test, touch a 12 volt bulb. It is not hot. Therefore, less energy goes to heat and more to light. And you can also have just, oh man, this is just so much information. We'll just keep to the basics. Keep to the basics. Basics. Oh yeah, propane refrigerators. Those are cool. Now here's more diagrams. This book only cost $16 back in the day. That's practically the same it is now. For us poor people, at least. Oh yeah, the reason why I'm doing this is I don't want anyone, well, sorry, I don't want any of you, Mr. Greedy fucking corporation man, to be able to make money off of people anymore. Because I hate you with a passion. Yes, lots of... Let's get to the basics to where we can explain what things mean. And I have over like 1,000 books in this house. I misspoke when I said like 3. There's so many freaking books here. Like, I'll go show you the collection, and you guys can comment what books you want me to read, because a lot of people can't get these rare freaking like first edition prints that I have. Like, they're not copies, they're all just really, really nice. And good. Wiring. A wire that is too long or too small for amperage passing through it will result in a voltage drop. If you are powering a 12-volt DC pump at 90% or 12 volts because of a 10% voltage drop in the wiring, then the pump will turn only 90% as fast and pump only 90% as much water. To put this into personal economic terms, if your whole home had a similar 10% voltage drop, then you would need to buy a 10% larger PV system. La-di-da. Yes, whole chapter dedicated to lighting, freaking appliances to avoid, la-da-da, la-da-da, la-da-da. Just keep it simple for now. Watts equals amps times volts. Amps equals watts over volts. Amps equal 1,200 watts over 12 volts, then amps equals 100. These are generalized instructions. Each individual system will have different parts, components, and mounting conditions, and must be customized accordingly. An electrician or other suitable professional, like anyone in the world, can install specific design for installation. Each installation should be inspected by nobody, because these are bullshit code rules to keep you in slavery. If these are used as complete installation instructions. La, 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 la. Blah, 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 blah. Blah, blah, blah. Blah, 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 blah. Blah, blah. Oh yeah, there's some more. More diagrams for you. Code, eh? I say go fuck yourself. I don't believe in it. Even if it's real, go fuck yourself. I'm God. I say no more bullshit code. Do what you want. If you burn your own house down, that's on you. And everyone has insurance, right? Even if you don't, Help the motherfucker out. He just burned his own house down. That's the right thing to do. Then help him out next time he wires his fucking house. That's it. Resources are unlimited. They are created by the planet. Anyone that lies to you and says otherwise is exactly what I just said. A liar. And plus, we got like crazy awesome new resources hitting the planet with asteroids and freaking fallen stars, everything breaking up in the atmosphere, blah blah blah. Plus, we already have pretty much everything we would ever need under the ocean, anyways, from all the fallen civilizations that have been here for like all of time. And considering the freaking Earth is just a gigantic flying fucking time machine spaceship, we've always had everything we need. I don't know why freaking anyone wants to blast off this fucking planet and go to other places, man. I mean, shit, when freaking most of the entire world's undiscovered and unexplored underneath our ocean blue, why the fuck would we fucking want to explore space before we fucking at least find out fucking all the answers that we don't know here? God dang. I hate humans that are freaking savage, barbaric, history-destroying motherfuckers. That's why I guard my books with guns. Big ones. Electrical theory. Remember, theory. But this is the theory they had back in the day, so come on. Get with it, people. Voltage in volts, V, is a potential difference in a circuit which makes current flow. Flow. Back in England, they used to freaking call it electrical pressure, because electricity and water move very much alike. Current, in amps, I, is an amount of electricity flowing past a point. Resistance, ohms, represented R, is the opposition to flow. The three basic units of electricity are algebraically related as follows. Voltage equals current times resistance. Volts equals amps times ohms. Voltage equals current times resistance. I equals V over R, or R equals V over I. Electrical power is the rate at which electrical energy is produced or used. Power is measured in watts and is product of the voltage and the current. An elementary understanding of electricity is essential to any remote site home owner. It is necessary in the design, use, and maintenance of a system, and in the selection of efficient appliances. The simplest familiarity with electrical theory allows an owner to monitor, troubleshoot, and design a photovoltaic system. The basic blocks of electricity are volts, amperes, and ohms. Electricity can be explained most easily when it is compared to the pressurized home water system. Volts are analogous to water, pressure that forces water through the piping. Amperes are analogous to the amount of water which passes through the pipes. And ohms are the resistance to the water flow that occurs when a nozzle is attached to the end of a hose. Blah. Oh yeah, some constant value, length of wire. If your freaking load drops, you need a freaking, if it's not pushing out the right amount, get bigger wire, shorter distance. Freaking, if it's freaking not, what's it called? Not able to keep up, double. Freaking double or half. Always double or half. Depending on what your problem is. Freaking, it's hard to explain what I read on camera, because whenever you freaking look into a camera, somehow it freaking lowers your IQ. So, Or at least that's my experience. This is why it's best to freaking watch God when he doesn't know you're watching. Because if you all work together on one thought and idea, it says in Genesis itself, you will become greater than I. That's why he made the Tower of Babel. AC, alternating current electricity which rapidly reverses its direction of flow. One forward, one reverse. Flow constant constitute one cycle. In the USA, the standard is 60 cycles a second. Amp or ampere, the unit of current flow in a circuit, specifically how many electrons flow past a given point each second. Ampere hour, a constant current flow of 1 ampere for 1 hour of time. This commonly used measure of battery storage capacity multiplied by the battery voltage will give the total electrical energy stored in watt hours. Array, a group of photovoltaic modules electrically connected together. Battery bank, a group of electrical storage batteries electrically connected together. Battery capacity, the amount of electrical energy in watt hours available from a battery. Battery cell, the basic structural unit of a battery. For example, a 6-volt battery is made up of 3 2-volt cells. Battery cycle life, the number of times a battery can be discharged and recharged again. The number of cycles is dependent upon the depth of discharge of each cycle. Charge controller, a device used to regulate the charging of a battery bank. Its function is to prevent overcharging of the battery bank while still allowing it to reach full charge. Charge rate, the battery charging current in amperes applied to a battery bank. Current, the rate of flow of electrons in a circuit measured in amperes. DC, direct current, the flow of electricity through a conductor from a positive to negative batteries and PV modules produce DC current. Electrolyte, a chemical such as sulfuric acid that electrically and chemically interconnects the positive and negative plates in a storage battery. Equalization, the process of recharging all cells of a battery bank to full charge. Equalizing charge, a charge at a voltage higher than which is normally used in battery charging, the purpose of which is to bring all the battery cells up to the same specific gravity. Gassing, hydrogen and oxygen released when water molecules are split as lead acid batteries are brought up to full charge. The loss of water from electrolyte solution requires the periodic addition of distilled water to lead acid batteries. Grid, the network of utility power distribution. Hertz or Hz, 1 cycle per second. The standard of utility AC electricity in the United States is 60 Hertz or 60 cycles a second. Isolation, the amount of solar energy available per area. Inverter, a device which converts low voltage DC electricity to 120 volt AC electricity. Kilowatt, 1,000 watts. Kilowatts hour, a measure of electrical energy equal to a kilowatt of power generated or consumed for a period of 1 hour. Line loss, the loss of electrical energy due to the resistance of the length of wire in a circuit. Load, the appliance or appliances that consume electrical energy. Open circuit voltage, the voltage between the positive and negative terminals of a PV module when the module is not connected to any load or battery. Overcharge, the charging of a battery beyond full charge. Panel, a colloquial term for a PV module. Peak sun hours, 1,000 watt hours per square meter for 1 hour, a unit of measure of all solar energy available at noon on a clear day at the Earth's surface. Photovoltaic or PV, the conversion of solar energy directly to electrical energy. Self-discharge rate, the rate at which a battery will gradually decrease its state or charge even though no loads exist. Self-regulating module, a PV module which is designed to decrease its output as a battery approaches full charge. Single crystal silicon, silicon grown from a single crystal which is sliced into thin wafers and used as the basic building block, the solar cell, in many PV module designs. Solar electricity, electricity produced directly from solar energy. State of charge, the percent of full charge that a battery currently has available. Sulfation, the change in normal crystalline structure or sulfite on the surface of a battery plate to more stable, larger crystals which increase resistance to normal battery charging. Voltage or volts, the potential difference or pressure in an electrical circuit which results in the flow of electrons. Watt. The unit of measure of electrical power. The product of current and voltage. Watts equals amps times volts. I'm assuming it's times because it's watts, x, and then volts. Watt hour. A measure of electrical energy equal to 1 watt of power used or produced over a 1 hour period of time. Oh, here's more code. Let's just nope. No. National Electrical Code. I can't read. I don't know. La 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 la. And that's the book. Hope you guys liked it. And let me show you what I was talking about library, man. Library, not library. Remember what frickin' the janitor from Scrubs said. Library. Never have kids. Oh yeah. Time flies when you're having rum. Oh yeah. This is my boy right here. Love that guy. Oh yeah, I'll just show you around my house. How about that? There's my dog. She's a good girl. Here's frickin' my mom's Pikachus and frickin' china cabinet. And then this gigantic thing I frickin' was had to help my dad frickin' get it here. Wasted all my frickin' Saturdays, frickin' I was just treated like the family slave pretty much. And here's my solar panel. Got it off of Wish. Fucking awesome. I had 3 of them. Sold the other one to my buddy because he needed it because he was going all van life and shit. And one of these things actually provides all the electricity he needs for his entire freaking setup. But I'll show you the freaking settings on it. There you can see the name, HQST, high quality solar technology. There's their email, so you can get it too. There's their telephone number. There's me name. Freaking, there's the warnings, blah, blah, blah. And then there's all the freaking what it can handle and all that cool stuff, But here's my library. It's what I grew up with. Books. And then, cassettes, more books, all that stuff. And here's knowledge that freaking got beamed into my head when I had 7 gallons of concentrated Anamita mascara mushroom wine. Powerful stuff. Had to write it down just because, I knew everybody else would just try to claim fucking, I don't know, whatever for it. Try and claim credit, and then I shared it with everyone, and I never got freaking a single mention. Sucks. Here's all my freaking cookbooks that I grew up with, and freaking family recipes and all that stuff. I'm an excellent chef. Freaking got freaking CDs, music, love all the music. Then we got our freaking world history yearbook, like encyclopedia things. Freaking grew up with all those too. Then we got all our freaking childcraft, freaking fantasy, freaking the Green Kingdom, Story of the Sea, About Us, holidays, birthdays, place to know, Megan Do. There's, pretty much everything you need to freaking have a child, have an active imagination so they don't end up brainwashed and stupid like most of the world. Oh yeah, and then, freaking world books. These things... Oh, here's my asshole brother and his friend. World books. Freaking world books. Books, 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 books. Books are good. Books are always good. Books are the best. Oh, yeah. Then these books: Babylonians, Hittites, Egyptians, Persians, Normans. Freaking just look at all these wonderful books. Books, books, books. Books, 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 books. Books, books, and pictures. Books and pictures. I'm the only one here freaking secluded by my family, outcasted, cast out, not recognized, yada, yada, yada. Hey, look, here's me. Hey, look, here's me as a child and a girl. And then, hey, look, here's me as a young kid and a girl. And look, here's me in Scotland at the Giant's Causeway. Hey, hey, I was fat and different looking. Hey, hey. I hope you guys enjoy.